I'm Anil Kumar sharing with you a test problem. I'd like you to pause the video, answer the question, and then look into my suggestion. The question is the piecewise function continuous? We are given this piecewise function f of x as equal to 1 minus absolute x when x is less than minus 1. It is equal to 1 for x equals to minus 1 and is equal to absolute x minus 1 for x greater than minus 1. Now we need to show whether this piecewise function is continuous or not. How will you do it? Think about it. Now, since the piece is joined at minus 1, the only point which we need to test is when x approaches minus 1, right? So as x approaches minus 1, what happens to the function? If it is continuous, then limit of the function and the value of the function as x approaches minus 1 should match, right? That's the key issue here, right? So what we're trying to find is right side and left side limits for the function as x approaches minus 1. So we'll find limit of the function f of x as x approaches minus 1 from left side. We'll try to find limit of the function f of x as x approaches minus 1 from the right side. They should be equal so that the limit of the function when x approaches minus 1 exists, right? So if both the above limits are same, then this will exist. And one more condition is that this limit should be equal to the value of function at minus 1. That means it should be, is it equal to f of minus 1? That means f of minus 1 is another thing which we need to figure out. So these are the three things which we need to find to conclude whether a piecewise function given to us is continuous or not. Okay, so let's start with the very first one, the left side limit for the function as x approaches minus 1. Now on the left side, it is the first piece which we are talking about, 1 minus absolute x. Now if you are approaching from the left side, you have to consider this value, right? So if I write minus 1, very, very close to minus 1, in that case, absolute value of minus 1 is going to be 1, and 1 minus 1 is going to be 0. So we are approaching a value 0 in this case. Therefore, the limit exists. The left side limit of the function is 0. Now let's consider the right side limit. That means we are talking about this piece, which is absolute x minus 1 when x is greater than minus 1. So when you're approaching from the right side, and if I substitute minus 1 for absolute x, I get 1, and 1 minus 1 is 0. So we get again 0. Now since both the above limits are same, 0, we say that the limit of the function exists and it is also 0, right? 0 is a valid number, correct? So the limit exists. But what is the value of the function at minus 1? Value of the function at minus 1 is number 1, right? Now value is different, right? Therefore, what we see here is we say that the function is discontinuous. Now the limit of the function f of x as x approaches minus 1 is equals to 0, whereas the value of the function f of minus 1 is equals to minus 1. It was 1, sorry. So at x equals to minus 1, it is 1. And since these two things are not the same, since limit of the function as x approaches minus 1 is not equal to the value of the function at minus 1, we say that the function is discontinuous, right? Therefore, it is discontinuous. So this is what we get from this example. So there is a possibility that the limit may exist, correct? But still the function is discontinuous, correct? So as an added exercise, I'll appreciate you can pause the video, sketch the graph, and check why the function is discontinuous, right? Now let me just make a rough sketch quickly for you, and then you can plug in some values and get a sketch. Now critical point for us is minus 1, so I'm just drawing a line here representing minus 1 for us, right? And another lines I'm drawing just to represent my unit 1. Since this is kind of a rough sketch, let me just get some grid kind of, right? And we know one thing, at x equals to -1 the value is 1, right? So this is the value of the function at -1. Now let's see the first piece, which is 1 minus absolute x when x is less than -1. So it's a good practice to make a table of values, right? So what we will do here is we kind of make a table of values. So it will help us, right, to accurately draw the graph. So we'll have x values and we'll have the value of the function. So if I consider a point, let us say left side -2, for example, let's say -2. If -2 is my value, absolute value of -2 is going to be 2, and 1 minus 2 is going to be -1. If I take the value as -1, for example, right, I know that that point is a hole, so we'll say a hole here, not a fixed value, but we need a reference. So 1 minus 1 is 0. We know the limit is 0, so it is approaching 0, right? So it is approaching, it is never there, right? Okay, if I take a value which is 1, for example, so 1 is greater than, well, let me take 0 first, right? So if I take 0 as my value, then that means greater than -1. 0 minus 1 will give me -1. If I take a value of 1, then 1 minus 1 will give me 0. And if I take a value of 2, then 2 minus 1 will give me +1. So these values will help me draw a good graph for the given function. So let's start with -2. So we have 1 here, -2 here. The value is -1. So this is 1 point for us, right? And then at -1, it is 0, but it's a hole. It is approaching this point, but it's not really that point. So this first piece is kind of like this. Do you see that? So that is my first piece. Now the value of the function at -1 is 1. So let me write 1 here. That's it. Now at 0, the function is -1. So this is my another point to connect. Then at 1, it is 0. So at 1, it is 0. Okay. And at 2, it is 1. So at 2, it is kind of 1 here. So that means these are the points to be connected. So I can connect these points, and there it goes, straight line. And from here, I can connect this, right? So that is the kind of graph which I have for the given function. So I'll write f of x here. As you can clearly see, if that is my x-axis, right? Now, if I'm approaching -1, this is -1. From the left side, I'm approaching 0, right? This x-axis itself. And even from the right side, I'm approaching 0. So the limit exists, but there is a discontinuity. There is a hole here, correct? And the value of the function is not the same as limit of the function. And that is the reason why the function is discontinuous or not continuous. I hope that makes things absolutely clear and you appreciate the concept. So the limit may exist, but still the function may be discontinuous. Reason will be that the value of the function is not the same as the limit of the function, correct? That's the gist of it. Thank you.